Welcome back, everyone. Here we are at chapter 12.3. In the previous sections, we were introduced to what a vector is, and then we found out how to find its magnitude and do a scalar multiple, how to add them, how to subtract them, how to draw them, and things like that. We are to the first part of multiplying two vectors together. There's actually two different ways to multiply two vectors together. We have the dot product, and then for the next video will be the cross product. So we're going to focus on the dot product right now. And our big formula for the dot product is vector A dot vector B. And what we do is we just multiply the first components together, added to the second components, multiplied together, added to the third components, added the whole thing up. And to be clear, the result of a dot product is a scalar. And if you remember what a scalar is, that's just a whole number. Now, that won't totally be true later in this chapter when we get to things like vector functions and things like that. But for right now, we're just dealing with nice, pretty whole numbers or fractions even. So let's go ahead and try this. We'll start with a two-dimensional vector. And this is going to be 2 times 3 plus 4 times -1. That's going to be 6 minus 4, or 2. Now, you might be wondering, what is the physical interpretation of a dot product? There really isn't one. It's just the dot product kind of comes up quite a bit in a lot of different processes. So for part B, we have two three-dimensional vectors, and so I'm going to multiply those out. Even if we have fractions in here, decimals or whatever it is, it's still the same process every time. And so that's going to give me 6. And we also can do the dot product when we were written with respect to the unit vectors. Notice that the I is missing in this case. So this is for the second vector. For the first vector, it's going to be 1. And then because it's missing, I'm going to put a 0 there. And match up the j's. That's going to be 2 times 2 plus -3 times -1. It's obviously 0 plus 4 plus 3 is 7. Not too bad, not too hard. And we have some properties of the dot product. So let's say we have our two vectors, A and B. Then A dot A, vector A dot vector A, is the same as the magnitude squared. These are really easy to show, not too bad. It is commutative, meaning A times B is the same as B times A. It's associative. We can move we can apply the distributive property. And it's associative, meaning we can move the parentheses around when we're multiplying. Now, I want to remind us for the number 5, the 0 vector is the vector that has all zeros for its components. And when you dot the 0 vector to any vector, we just get a result of the number 0. Now, this is not the 0 vector. This is literally just the number 0. The dot product can be given in a geometric interpretation. And the way you get this the formula I'm about to highlight here is we use a lot of cosines. I'm not going to get too into it. But our theorem says basically A dot B can be defined as the magnitude of vector A times the magnitude of vector B times the cosine of the angle between the two vectors. So you can see right here, theta is that angle between vector A and vector B, which will work for us because we're going to end up trying to go the other way to find out what that angle is. So let's go ahead and do an example. If we have vectors A and B, have lengths 4 and 6. Oh, I see. So the magnitude of vector A is 4, and the magnitude of vector B is 6. And theta is pi over 3. Then find the dot product. All right, but we're going to use our formula up here. A dot B is the magnitude of A times the magnitude of B times the cosine of the angle between them, which in this case is pi over 3. Cosine of pi over 3 is 1/2, so this is going to be 24 times 1/2, giving us 12. So we didn't even need the components for this one to be able to find the dot product because we have our new formula. Now, straight from this, you can see if I were to take this formula here and divide both sides by the magnitude of A and the magnitude of B to both sides of the equation, then we get this as a result. And this is what we're going to use to find the angle between any two given vectors. So here we have two new vectors, vector A and vector B, and we want to find the angle between them. So first off, I'm going to need the dot product. And again, that's going to be 2 times 5 plus 2 times -3 plus -1 times 2. It's going to be 10 minus 6 minus 2. That's going to give us 2 there. I'm also going to need the magnitude of A. If you remember the formula for that, this is 2 squared plus 2 squared plus -1 squared. And that's 4 plus 4 plus 1, that's 9, giving us 3. And the magnitude of vector B is going to be the square root of 5 squared plus -3 squared plus 2 squared. And that is going to give us 25 plus 9 plus 4 is root 38. Remember, when you square negative, it becomes positive. Just be real careful. Now that tells us that the cosine of theta is going to be 2 divided by 3 times root 38. Now, on my calculator, what I want to do is I'm going to go into mode and make sure that I am in degree mode. So I have to switch mine to degree mode. Make sure that you do that. This is one of the few times in calculus that we actually use degrees, is to find the area between a vector. So now I can do inverse cosine of 2 divided by, and I'm going to use extra parentheses here, 3 times the square root of 38. And that gives us 80. So this means theta is about 83.79 degrees. Now, your teacher, you'll need to ask your teacher if they want it in degrees or radians, especially if it doesn't say. If they wanted it in radians, then I'd have to go back and switch back to radians. All right, let's keep going and find the angle between two more. So I'm going to need to find A dot B. So that's going to be 4 times 2. Notice the J term, vector J is missing in the second, in vector B. So this gives me -3 times 0, and then 1 times -1. Let's see what we get. 8 and 0 minus 1, so it's going to be 7. Magnitude of A, square root of 4 squared minus plus -3 squared plus 1 squared. So let's see. 16 plus 9 plus 1. I'm getting root 26. And for vector b, I'm getting the square root of 2 squared plus 0 squared plus -1 squared. You might be wondering, do I have to put the 0 in there? No, you don't, if you already know that it's going to be missing. So that's 4 plus 1, that's root 5. And now let's find the angle between. So we have the cosine of theta is equal to 7 divided by root 5 times root 26. In the calculator, I'm going to put that all under one radical. So second cosine, 7 divided by square root of 5 times 26. So this means that theta is about 52.13 degrees, if we round that properly, is the angle between these two vectors. Not too bad, not too difficult. So if we have two perpendicular, or orthogonal is the better word for perpendicular, it's a little bit more descriptive. But you can say perpendicular, but you'll hear me use the word orthogonal, and most likely your teacher will use orthogonal as well. Now, they are orthogonal if the angle between them is pi over 2. So if the angle between them is pi over 2, the cosine of pi over 2 is 0. So if you want to know if two vectors are orthogonal or perpendicular to one another, if you just dot them and you get 0, that means they're perpendicular, they're orthogonal. And so they're showing that these two are orthogonal. So what we'll do is we'll just dot them. So A dot B. That's going to be 2 times 5 plus 2 times -4 plus -1 times 2. That gives me 10 minus 8 minus 2, and we can see that gives me 0. Therefore, vector A and vector B are orthogonal. Or perpendicular. Meaning the angle between them is a 90-degree angle or a pi over 2 angle. All right, let's move on to direction cosines. And we have 3 of these, and we have 3 formulas that we're going to be dealing with. And we can see that we have 3 angles. Now, these angles, what they represent are the angles relative to the x, y, and z axes, meaning the ones that are relative to vector I, vector j, vector k. And let's do this. All right, so find the direction angles of vector A, which is 1, 2, and 3. So the first thing that I'm going to need is I need the magnitude of A. So let's find that over here real quick. Magnitude of vector A. Square root of 1 squared plus 2 squared plus 3 squared. That gives me 1 plus 4, which is 5. 5 plus 9 is 14. So I have that. So let's start with, let's keep our formulas on the screen here. Cosine of alpha is vector A, the first component of vector A, pardon me. So that's going to be 1 over the magnitude of A, which in this case is root 14. Which means that alpha is the inverse cosine of 1 over root 14. So let's see what we get with that. Again, make sure you're in degree mode. By the way, a student asked me, why do you keep reminding us over and over again about the degree mode thing? That's because every math teacher has made a mistake numerous times by not having you on the right mode. Ask all of them. It doesn't say where to run it off, so I'll go 74.5 degrees. So relative to vector I and our vector A, the angle between vector I and vector A is about 74.5 degrees. All right, let's find the other two. So next up, cosine of beta, that's the angle between vector J and our vector A. That is going to be component number 2, that's going to be a 2, divided by the magnitude of A, which is 14, root 14, which means beta is inverse cosine of 2 over root 14. So inverse cosine of 2 divided by the square root of 14. So I'm getting that beta is about 57.7. 57.7 degrees. Double check that. 57.7, yeah. And for our last one, we have cosine of gamma is the third component, which is 3 divided by magnitude, which is root 14. So gamma is the inverse cosine of 3 over root 14. Square root 14. So gamma is about 36.7 degrees. Not too bad. All right. So find the direction angles of the vector A, which is, I'm going to rewrite this. So all the C's are positive, it's saying. So vector A is C, C, C. And I'm going to go ahead and find the magnitude of vector A. So this is C root 3. And because they told us that C is positive, we don't have to worry about the square root of C squared being an absolute value or anything like that. All right, so let's use our formulas here. So we have cosine of alpha is the first component, which is C, over the magnitude, which is C root 3. And the C's reduce out. And I'm hoping you can see we are going to get the same angle for all three of these because they're all going to do the exact same thing. So let's go ahead and do inverse cosine. Inverse cosine of 1 divided by the square root of 3. This means alpha is about 54.7 degrees. And actually, because C is the same for all of them, we're going to get the same answer for all three. Oops. So cosine of beta is also going to be C over C root 3, which is 1 over root 3, which means beta is the same as alpha. 54.7 degrees. Which makes, of course, gamma the same. means gamma is 54.7 degrees. And that is the dot product. I hope you found that helpful.